Yeah, my name is Keith Soll and I'm a mechanical engineer at the German Aerospace Center in Göttingen in Germany. So we are here in Bruchsal at Volocopter for the ground vibration test of the new Volocity. So we are exciting the aircraft. We've got 182 accelerometers distributed across the structure, and we use these to measure acceleration. And then we have electrodynamic shakers which excite it with different signals, and we can measure the response and create a so-called data-driven modal model. And this can be used by Volocopter for things like model updating and to certify the aircraft before first flight. In real flight, there are of course forces on the aircraft from things like gust loads or from the wind, and this can cause the aircraft to bend and to flex and to move in different ways. And we speak about mode shapes, so each structure, whether it's a tree or a pole or a human body or an aircraft, it has these so-called modes. And when we can collect enough of these modes together, we can build a model which represents the structure. And this allows us to create a so-called mapping where we can say certain input forces result in certain responses, and this has a physical meaning to keep the aircraft safe. So we test the aircraft with different forces, which is meant to simulate, for example, the loading of the aircraft in actual flight conditions. And we start always at a lower level and work towards the upper boundary. And the point is to clear the aircraft in the flight envelope. Volocity is something quite unique and quite special in some new ways. So we've used the experience that we have, and we use certain techniques which we know well, but this application has required some new innovations.